All right, good afternoon and welcome to Master Talker online class. In today's video, we'll be talking about Boyle's law. All right, Boyle's law. All right, in 1662, 1662, right, a scientist called Boyce, he named it after his name. A scientist called Boyce investigated the relationship between volume and pressure of a gas. Write that, okay? And his findings was later named after him. So therefore, Boyle's law stated that you can write that the volume of a given mass of gas is inversely proportional to pressure, provided that temperature and the number of moles remain constant. Okay, this means that Boyle's law depends on temperature and number of moles. So if the temperature and number of moles remains constant, then you can now conclude that the volume of a given mass of gas is inversely 1 over inversely proportional to pressure. Okay, so now what do we have now? That volume V, if you want to remove proportionality sign, you bring in a constant. Volume times what? K times 1 over P. So which is what? Volume is equal to what? K over P. So if you cross multiply, you will now see that K is equal to what? Vp. All right? K is equal to Vp. Where so from here you can have that V1 P1 is equal to what? V2 P2. Right? This formula is very, very important. Where, please write, where V is equal to volume, okay? Volume, and P is what? Is pressure. Is pressure. And then my K is what? Proportionality constant. Proportionality constant. All right? Okay. So from this now, we can now solve some calculations on Boyle's law. So now if we want all the V to be at one place and all the P to be at one place, we'll have that what? V1 over P1, V1 over V2, okay? V1 over V2 is equal to what? P1 over P2, okay? Then any of them that you like, if you like V1 P1 is equal to V2 P2, is very, very okay. So right, note the proportionality constant K equally depends on temperature and number of mole. This means that the factor affecting Boyle's law are temperature and the number of mole. So note that, very important. They can ask you the factors that are affecting Boyle's law are dash and dash. It is what? Temperature and the number of mole. So let us solve some calculation that will help us to understand this very well. Example, the first question said that the volume of a fixed mass of gas, the volume of a fixed mass of gas, okay, at a pressure of 500 millimeter mercury. And don't forget that I told you that millimeter mercury is the same thing as what? Think millimeter mercury. You can check. I think it's bar. Yeah, I think so. So no, it's the same as Pascal. Abi bar. The same thing as bar, because Newton per meter is Pascal. Newton per meter square is Pascal. Yes. So millimeter mercury is bar. Then ATM is the same thing as what did I call it? You can check my former video anyways. So we have that so we have this as millimeter mercury. So the next thing we should look at is 550 cm3. All right. It said that the volume of a fixed mass of gas at the pressure of 500 millimeter mercury is 50 cm3. Then I say find the volume. Okay. Find the volume when the pressure is 600 millimeter mercury. Okay, solution. This is very, very simple. So what do? You get your parameter. They gave us the first volume they gave us is 50 cm3. All right. Then they gave us pressure. The first pressure they gave us is what? Is 500 millimeter mercury. Okay. And they say we should now find V2, the second volume, when the P2 is equal to 600 millimeter mercury. Okay. So, but we know a formula. Permit me to solve here. We know a formula that said that what? P1V1 is equal to what? P2V2. So substitute to have the what? Pressure 500 times times 50 is equal to what? 600 times the V2 I'm looking for. So if you make V2 subject of formula, you divide everybody by 600. So now have that V2 is equal to 500 times 50 divided by 600. So this will now give you 41 41.67 cm cube, right? So this is very, very simple to calculate. So let's go to the next question. The next question said, at what, number 2, at what, sorry, okay, at a volume of 300 cm cube, the pressure of a gas is 2 atm. It is 2 atm. Then I say find the pressure when the volume is doubled. Okay, this is very simple. Solution. Okay, they gave us that V1 is equal to 300 cm cube, and then P1 is what? 2 atm. Okay, so now they now say that the V2, that the volume now is doubled. Double means 2 times that V1, which is what? 2 times 300, which is what? 600 cm cube. And they're now asking us the pressure. The P2 is unknown. So what do? We use the same formula that say that P1 V1 is equal to P2 V2. So if you put it here, you have that what? 2 atm times 300 is equal to P2 that I'm looking for times 600. So what do we have? We now have that P2 will now be what? 2 times 300 divided by 600. So what do you have? 1 atm, right? So that is that. Very, very simple. So look at the next question. The next question said, the final volume, number 3, the final volume of a fixed mass of gas, is 3 times its initial volume. All right, at constant temperature and number of mole. All right, then I say calculate the ratio of final pressure to the initial pressure. Okay, so our parameters, they gave us solution. Okay, they said that V1, let's call V1 to be the same thing as V1. Then, but they said that V2 is what? 3 times that V1, which is what? 3V1. All right, so we don't know the final and the initial pressure. So let the initial pressure be P1 and the final pressure be P2. So what do we have? We still have the same formula, that P1 V1 is equal to P2 V2. So my P1 is still my P1, okay, times my V1. My V1 is still my V1 is equal to my P2 is what I'm looking for. Okay, no, my P2 is my P2 times my V2 is what? 3V1. And they said find the ratio of the final. They mentioned the final before the initial. So you are the final should be on top and the initial will not be below. Are you getting me? So this one will come down, this one will go down here. Okay, because I want the P2 to be up. If you want the P2 to be up, if this person is going down, then this person will come down. So what does it mean? That my P2 being up divided by, this is multiplying this, so moving here will now be divided by P1. Are you getting me? Is equal to, then this one is now here. V1 is already here before the 3V1 will now come and meet him there to become 3V1. Are you getting it? Um, everybody will be at the same side. Or we can equally use that our formula that say that P1 V1 V1 over V2 is equal to P1 over P2. If you like that one, you will still get the same answer as well. Okay, so now you now see that what P2 over P1 is equal to what 1 over 3, because V1 will cancel V1. So therefore P2, the ratio of P2 is to P1 is equal to what 1 is to 3. Are you getting it? So that is the ratio of the first volume to the second volume. So which means that the first pressure is 3 times the second pressure. Are you getting it? And that is Boyle's law. Boyle's law says that if the volume is increasing, you look at the volume increased here by 3. So the pressure is supposed to decrease by 3 here. And that is exactly what we got. Okay? So we'll go to the next question. So the next question here said, the next question said, number 4, said that what? The ratio of initial to the final pressure of a gas of a given mass of a gas, okay, is 1:1.5. Then I say calculate the final volume. Calculate the final volume of the gas if its initial volume is 300 cm cube. All right. Okay. So solution. They say that the ratio, that is P1 over P2 means ratio. Okay. This is the initial to the final. That is 1/1.5. You're getting it now. So which means my P1 is going to be 1 and my P2 will be 1.5. Then my V1 is what? 300. So we need my V2. My V2 is unknown. So I still know my formula that said that P1 V1 is equal to P2 V2. So what do I have? So I have that what? 1 times 300 is equal to what? 1.5 times V2. So therefore my V2 will now be 300 divided by 1.5. So what do you have? 300 divided by 1.5 will give you 200 cm cube. All right? 200 cm cube. So question number 5, we are moving. See, this is very, very simple. This is very, very simple. So we'll go to the question number 5. Question number 5 said the final volume of a fixed mass of a gas is 1/4 of its initial volume. All right, at 740 millimeter mercury, right? At 740 millimeter mercury. All right, then full stop. They say that at constant temperature and number of mole, comma, calculate the ratio of its initial to final pressure. Okay, calculate the ratio of its initial to the final pressure. Solution. Now my initial volume, let me call it V1. That is V1. Then my final volume V2, they said it is 1 over 4 times that initial volume. Okay, so that is what? V over 4. V over 4. V1 over 4. Okay, we still know our formula that said that what? P1 V1 is equal to P2 V2. And they say we should calculate the ratio of each initial. They mentioned the initial before the final. So let me make this one to come down to have that P1 over P2 is equal to V2 over what? V1. Okay. So that is that. Please, the other formula I gave, V1 over V2 is equal to P1 over P2, is very wrong. If this one is like this, then P2 should come up. P2 should come up so that P1 will be down. So please note this, please. That thing I gave there is very wrong. So that is how it's supposed to be if you want to get their ratio. So therefore, P1 over P2 is equal to, what is my V2? My V2 is what? V1 over 4, then divided by V1 again. All right. So it's going to be what? P1 over P2 is equal to what? V1 over 4 divided by V1 over 1. All right. Which will give you what? P1 over P2 is equal to what? V1 over 4 times 1 over V1. So this one will cancel this to have what? 1 over 4. So the ratio, permit me to finish it here. The ratio P1 is to P2 is equal to 1 is to 4. So that is the ratio between the two of them. Right? 1 is to 4. All right. So that is that. Okay. All right. So we're going to enter Charles' law, but before we enter Charles' law, we need to represent Boyle's law in a graph, graphical representation of Boyle's law. Right, a graphical representation of Boyle's law, graphical representation of Boyle's law. Right, graphical representation of Boyle's law. Now, look at how to represent Boyle's law. You have your P is to V. Your P is here, and then your 1 over V inversely. Don't forget, 1 over V. If it is like this, is a straight line graph. But if you start with your V, if you want to get, if you have P and V like this, then it's going to be something like L like this. Okay, so you need to take note of it. Then the third one is if I have PV, if I have PV here and then I have P here, then it's going to be a straight line like this. Then finally, if I have log P against 1 over against log V, against log V, all right, they said it's going to be like this. So you should note the different diagram. So this is what? Graphical representation of Boyle's law. All right. Okay. So the next one. So let's talk about how kinetic energy explains Boyle's law. Write that down. How kinetic energy explains Boyle's law. Write it. How kinetic energy, subheading. How kinetic energy explains Boyle's law. Okay. Now let's consider a gas enclosed in a vessel with a movable piston, which is made to be stationary by placing a stable weight on it. At constant temperature, the average velocity of the gas molecule will be constant, and the number of the collision of the gas molecule with one another and to the walls of the container will equally be constant. In other words, at constant temperature and pressure, at constant temperature, the pressure and volume of the gas is constant, as shown in the next, as shown below. Okay. Okay, as shown below, we have this. All right, we have this and we have this one like this. Please, you have to draw. All right, so this one goes this way and I have this. Okay, so volume is constant, pressure is constant, and then the temperature is constant. All right, all right. So now, if if the weight if the weight in the piston is replaced by a lighter one, the piston will move up, okay, thereby making the volume of the gas to increase. All right, while the number of collision made by the gas particles uh, to one another and to the walls of the vessel will decrease because they are now far apart. Therefore, when the volume is increased, the pressure of the gas will be decreased as shown below. So now, if we replace this one now, if we replace this one with another one, if we replace it with a lighter one, so another one that is a little bit light, you see what will happen. You will notice that the volume will increase, and if the volume increases, they now have space. They have more space, and when they have more space, the pressure will reduce. But when you compress it, you understand, the volume has reduced, then they will now be fighting very well. Okay, so which will now make the this thing to reduce. Okay, sorry, that will not make the pressure to what, to increase. Okay, so that is that. So another way to do it is the third way is what, when you replace it with a heavier one. If you replace it with a heavier one, compressing it more. If you replace it with a heavier one, compressing it more, maybe compress it to this point. Are you getting it? You see that something happened, that they are now fighting with so much pressure, so the pressure will increase. Okay, so the pressure there will now increase with a heavier one. Okay, so the more you compress it, the more they are now fighting themselves, moving like they could not stay, so it will make their pressure to increase. Okay, but if you allow them freely, they will not be moving, they will reduce their pressure. So that is how kinetic theory explains Boyle's law. So let's move to the next one, which is Charles' law. The next one, Charles' law. All right, permit me to check my time. Okay, all right. So I think in the next video we'll now talk about Charles' law. I want us to take it one after the other. Okay, and don't forget that at constant temperature and number of mole, that the volume of a given mass of gas is inversely proportional to what, pressure. So you now have that if you remove proportionality sign, you have K over P, then which shows that V1, that K is equal to Vp. K is equal to Vp. Okay, so you now call that V1 P1 is equal to V2 P2. If you want it to be, if you want all the volume to be at the same side, this one will come down while this one will go down. So I have V1 over V2 is equal to P2 up over what, P1. Please correct the first one I wrote. Okay, this is the correct thing to write. So thank you very much for this particular video. In our next video, we'll talk about Charles' law. God bless you.